The observable universe is our biggest cosmic playground. It stretches as far as our most advanced telescopes can see, but the unfortunate truth is that no matter what we do, we are forever confined within this limit, always unable to see what lies beyond our cosmic bubble. To understand why we can't ever see past the observable universe, we have to first understand just how vast the observable universe truly is. According to recent estimates, it's suggested that the diameter of the observable universe exceeds a mind-boggling 92 billion light-years. And remember, a light-year is not a measure of time, but rather a measure of distance, over 6 trillion miles or 9 trillion kilometers. Now here's another mind-bending twist. When we gaze into the cosmos, we're actually peering back in time. How? Time traveling through light is possible because it takes time for light to travel from distant objects to our eyes. For instance, the light from our sun takes over 8 minutes to traverse the vast expanse of space and reach our eyes. So when we look at the sun, we're actually witnessing its appearance from 8 minutes in the past. This rule is consistent with all the things in the universe. The farther an object is in space, the longer its light takes to reach us, and as a result, the farther back in its past we look at. Our closest star to the sun is Proxima Centauri. In fact, Proxima Centauri is so close to us that we can actually see the light from its stars in the night sky with just our eyes. However, even though Alpha Centauri is our cosmic neighbor, the star is still an unfathomable distance away from us, over 4 light-years away from Earth. And because the light from any object in space takes time to travel to us, we are actually seeing light from Alpha Centauri that left the star system over 4 years ago. For all we know, Alpha Centauri could have been destroyed by a cataclysmic explosion yesterday, and we wouldn't find out about it until 4 years later. Now let's tackle the main question at hand. Why can't we ever see beyond the edge of the observable universe, even with future advances in technology? The quick answer lies in the fact that objects beyond that limit are moving away from us at speeds faster than light. I know it sounds like a contradiction. As we've been told, nothing can surpass the speed of light in the universe. But trust me, things are moving away from us at speeds that are far greater than the speed of light. So let's dive into the mind-boggling concept of galaxies, seemingly defying the laws of nature by hurtling away from us at speeds greater than the speed of light. Here's where the great mind of Edwin Hubble and his lore come into play, the same scientist who the Hubble telescope was named after. Hubble's law is a universal law thought of by Edwin Hubble, and is similar to the law of gravity on the basis that it is a fundamental aspect of the universe that cannot be changed. Hubble's law states that a distant object's speed, or velocity of recession, just a fancy way of saying the speed of its movement away from us, is directly proportional to its distance from us. How do we know Hubble was right? Once again, it's all thanks to the power of light. As objects move away from us in space, the wavelengths of their emitted light get stretched, resulting in a phenomenon called redshift. The faster objects recede from us, the more pronounced the stretching of their light waves becomes, leading to a greater redshift. It's a direct correlation between the speed of recession and the degree of redshift. Now here's the biggest secret to how galaxies are moving so far away from us at an alarming rate. It's not actually the galaxies themselves that are speeding away from us. It's the expansion of the nothingness of space between them that's really expanding. But now that leads to even more questions. How can nothing expand? Well, picture a deflated balloon representing the whole of the universe. Mark 2 points on its surface. These points are now 2 galaxies, and all of the rest of the balloon is the vast nothingness of space. And as you inflate the balloon, the points move away from each other, increasing the distance between them. Keep in mind that the marked points themselves never moved an inch. It's the stretching of the balloon's surface that caused the space between them to expand. In the vast expanse of the universe, galaxies play the role of those marked points on the balloon's surface. As space expands, it stretches the very fabric of the universe, carrying galaxies along for the ride. This expansion rate mirrors the inflation of the balloon. It's important to note that the nothingness of space is often a tricky concept to grasp, and it is not a complete void. Instead, the empty space of the universe refers to the absence of significant matter or objects on a cosmic scale. The expansion of space itself doesn't violate the speed of light because it doesn't involve objects moving through space. It's instead just the stretching and growth of space itself. Recall that we mentioned how objects farther away from us seem to move away faster. That's because they have more space to expand between us and them. As a result, the expansion causes these distant objects to move away from us at a faster rate compared to objects that are relatively closer. This apparent motion is not due to the galaxies themselves moving through space, but rather the expansion of space stretching the distances between them. The galaxies are essentially carried along with the expanding fabric of the universe. Now let's imagine the implications of this expansion. The farther away an object is from us, the more time it takes for its light to reach us. As we look deeper into space, we are essentially looking further back in time. The light that reaches our eyes has sometimes traveled for millions, even billions of years before reaching us. We can witness distant galaxies as they appeared billions of years ago, offering a glimpse into the history of our universe. But why can't we see beyond the edge of the observable universe? Simple. Remember Hubble's law. The farther away an object is from us, the faster the space between us and them. If an object is far enough, the space between us and the object is expanding so fast that the expansion seems to go beyond even the speed of light. Remember, the expansion of space itself is not constrained by the speed of light. It's not that these objects have reached a speed exceeding the cosmic speed limit. Instead, the space between us and them has stretched to such an extent that the light they emit cannot catch up to us. So, while we have made tremendous technological advancements, allowing us to explore the farthest reaches of the observable universe, there will always be a cosmic horizon beyond which we cannot see. It remains forever out of reach, as the expansion of space continues to carry objects away from us at speeds that defy our intuitive understanding. The mysteries and vastness of the universe are truly awe-inspiring. Who knows? Maybe there is truly life out there, but we have yet to find them because they live beyond our reaches of space. Maybe aliens are a new development in our universe, and we are yet to find them because the lights from their planets are only showing us how their planets looked billions of years ago. Just imagine aliens that lived on a planet over 4 billion light years away, looking at the Earth with a giant telescope. They won't see the blue marble we've grown to love. Instead, they'll see a giant fireball devoid of all life, because light shows you how things were. It will never show you how things are.